Okay. Oops. Okay, so hopefully it is recording now. So we get to record here. Okay. So welcome to, oh, it should be MathStat341, bad typo. I was changing from something previous. So this is MathStat341 probability. What's nice is when we have a smaller class, we've taught this class, I think, 3 in the last 4 semesters. There's much more of a chance now to adjust the content of the material a little bit based on what you find interesting. All right, so it's not working. Okay, all right. So just, a couple of standard stuff. So the goal is to be able to model things in the real world to predict likelihoods of events. Out of curiosity, how many people consider themselves more theoretical? How many people consider themselves more applied in statistics? Okay, just good to get a rough sense. How many people are algebra? Okay, so I actually like to do both. I was trained as a theoretical mathematician. I am married to a professor of marketing, and I've actually done a lot of applied projects over the years. There will be occasional equipment malfunctions when I talk about applying math and stats in the real world. But I want to share with you what you need to do to be able to use probability in a meaningful way to solve problems. So I used to tell students that if you knew 3 things, you would always have a job: probability, statistics, and programming. There was a lawsuit at another school a couple of years ago where somebody sued because she did not get a job upon graduation. And because of the Freedom of Information Act, you can actually download the lawsuit, where she misspells words like tuition, and has come up with a new type of discrimination, academic discrimination. Her school did not do as much for her as they did for people with higher GPAs. And her 2.7 was just as good as someone else's 3.7. So because of the threat of lawsuits, I can no longer promise that you will have a job if you know probability, statistics, and programming. However, I will be shocked if you know these 3 things and you can't find a job or find a way to be useful with these things. It's a terrific set. I do not care what language you program in. If you want to use R, Mathematica, MATLAB, Python, whatever, however you want to do the calculations is fine. Depending on what you choose, I may be able to help you with the actual coding. If not, I can help you with the pseudocoding. And I will be requiring you to learn some type of programming. You are not going to have to write 50,000 lines of code. You're going to have to be able to write code to maybe simulate shuffling a deck of cards, dealing out a hand of 5, and seeing, do I have 2 kings? Something along those lines so that you can gather data and make inferences from the data. How many of you are econ or interested in econ? Okay, so for those of you, you know, or you will learn as you go further in economics, that it is unlikely that you will get a closed form answer for any problem you're looking at. That you will have to do massive Monte Carlo simulations. And I'll actually talk to you later in the semester about the theory of these simulations. I'm just seeing somebody looking outside and I'm wondering if they're one of ours. All right, so objectives. Obviously, to learn probability. I want to emphasize the techniques of the subject. So I don't want you to just be computing. I want you to have an understanding of why the different approaches work. How can we get to the nice answer? So I'm actually finishing up a chess problem that I'm working on with a student from last year's class and another professor here on the stats side of the department, which has a beautiful answer at the end. I'll give you the problem right now to think about. So imagine you have an n by n chessboard and you place n rooks uniformly at random on the board. So a rook can attack horizontally, a rook can attack vertically. What is the probability that at least one square on the board is safe as n gets very, very large? Better yet, what fraction of the spaces on the board are safe as n gets really, really large? Or even better, we haven't done this part, what can you say about the fluctuations about the average as n gets very, very large? And it turns out that the fraction of spaces that are safe has a beautiful answer. There's a lot of algebra, and it's how do you do the algebra the right way so that when the dust settles, you have something nice. If you have something nice, you have the ability to make inferences. Frequently we want a solution involving some parameters of interest, and then we vary the parameters and we see how things change. It would be great to see, oh, let's change tax policy by changing this and see what that does to revenues for the government. We don't have an explicit formula like that. We have models, we have simulations, and it's time consuming to do that again and again and again. If you can get something in closed form, that's much better. So we'll talk a lot about modeling problems. I'll talk a lot about elegant solutions versus brute force. There are times when, unfortunately, all we can do is just do the calculation. And then I will talk a lot about how do you look at equations and get a sense of what they're saying. And so by the end of the semester, you'll be trained like Pavlov's dogs, so that when you see certain things, you will be thinking, I should look at it this way. This is experience. The more times you see things, the better you get at it. When you're doing calculus, eventually you start to see, oh, this is probably a partial fraction. This is probably an integration by parts. You get to see stuff like that. Anybody here who is taking differential equations? All right, so I'll just so the first time I'll just focus to you. The first time I taught differential equations, I had a newborn baby daughter. And I taught the class as a father with a new daughter. Oh, daughter's crying. Does she want to be held? Does she want filled? Does she need to be rubbed? Oh, I have a differential equation. Is it exact? Is it separable? You have a bunch of things you just try. And then after a while, oh, that's the cry that wants to be held. That's the cry that wants the bottle. It's the same thing with a lot of mathematics. Is after a while, you start to look at things and you start to recognize how you should be attacking things. All right, I'll get to that. So there's a lot of different types of problems we can study. It's just a small subset of things. If there is something that you are very interested in, let me know. I'm trying to see any bridge players here. So in previous years, I've actually done sessions to teach people how to play bridge. It's a very nice, fun card game. But a lot of it is trying to estimate, do I play for a certain card to fall or not fall? Who do I expect is going to have the card among the opposition? A lot of good probability. In fact, a lot of the subject was inspired by people trying to figure out what are the odds of winning various games of chance. We will talk about some games from Vegas later in the semester. Sadly, we will never successfully analyze a game where the odds will be in your favor and you should go. If that were the case, I would not be here. Or I would not be wearing, as my daughter points out, a Rubik's Cube shirt, which looks like it has a pocket but doesn't, and actually you can't have red on red, this cube is wrong. All right, so my experiences, so this is just a subset. My wife is a professor of marketing. Through her, I've worked with a lot of marketing professors on applied projects over a couple of years. I've also worked at teaching operations research right before this. I've worked with a lot of local companies and trying to apply mathematics to help them with various things. Frequently, people feel like, oh, I'm not valuable. I don't know enough to be useful. No, you just have to do better than is being done. That's a much lower bar than perfection and finding the optimal answer. And a lot of times, there are tremendous inefficiency, or people have no knowledge of, wait, we could use statistics to estimate this? Yes. And so you often have useful skills. If you want to do a project for the class, either theoretical or applied, happy to talk to you about that. I'll say more words on that later. More applied experience. One of my favorite topics is Benefit's law of digit bias. And when, let's see, you were here earlier today? Yeah, so you can tell me how different the story is. Okay. So when I was a newly minted PhD student, just got it, started my postdoc career, I get an email one day, which begins, greetings, my name is David Kelly, I'm a senior criminal investigator at the Internal Revenue Service. And you're just, yeah. And after a minute or two of dread, I read the rest of the email. And the next sentence is, I just read with interest your recent paper in Acta Arithmetica. I'm just floored that somebody is reading any of my papers, but the Internal Revenue Service is reading number theory journal. So the Internal Revenue Service has finite resources. They are very concerned with detecting tax fraud. And it turns out people are terrible random number generators. One of the standard problems you often do in probability is you split the class in half. Half the students simulate flipping a coin 100 times. The other half actually flip a coin 100 times. And there's several tests you can do, and with extremely high likelihood, you can tell that the coin flipped or was it simulated. The thing that people know about is it should be roughly half heads, half tails. But there are other tests that people don't know about as well. One test that people don't know about is digit bias. That for a lot of sequences of data, you have a 1 occurring as the leading digit far more often than you would expect, about 30% of the time. And so the IRS is very interested in stuff like this. It is the only time I have given a talk where people told me before I begin, just to let you know, the following people in this room are out. I'll give a good talk tonight. Okay. The last one I want to mention is sabermetrics applying math to sports. So last year, I had 4 freshmen and a senior, the senior's now at the New York Mets, who worked with me on a Major League Baseball lawsuit. And the problem was you had a former All-Star who claimed surgery was done incorrectly and cost them the rest of their career. And the question was, assuming the surgery was done incorrectly, what value should you assign their expected earnings for the rest of the career based on their numbers to date? And so I'm happy to talk about applications and stuff like that. Right. Course mechanics, you'll be moving at a fast pace. Class participation is 5%. Please come to class prepared, read the book. The more prepared you are for class, the easier it will be typically to understand what's going on. Now, we have an interesting opportunity here. This is a small class. I want to do a little bit of an experiment. I have recorded all of my lectures from previous years. What I would like to do is actually move some of the new material and lectures to videos for you to watch and free up far more time in class for discussion and problem sessions. And actually just really work through a bunch of things. And one of the advantages of this is people can read and learn material at different paces. And so if we have some of the material that's a little bit more standard, let's try to move that to online, to reading the book or coming to the office hours, and then have more time to actually go through, let's take some really hard problems and let's work them out in class. So we'll talk to you a little bit about that. We'll also have a couple of guest speakers. We have a really interesting one who's going to be coming in, who'll be talking to us about card shuffling tricks. Some of these things are just good skills to have. Midterm is 40%. If there are 2 exams, only the best counts, unless you tell me otherwise. No one has ever told me otherwise. When I was at, I just say this because when I was at Brown, if you got a low grade, you could choose not to have it on your transcript. But only if it was a D, I think, or an F, but not a C. And so some students did not want a C. And so I would tell them, no, I'm sorry, whatever you grade as your grade, that's going to be your grade for the semester. If you want to color on the final and not answer any problems, that's fine. But if you give me an exam to grade, I will grade the exam. So other than that, no one has ever told me, please, count the lower exam. So I will assume, unless you tell me otherwise, that I will count always the best things for you. So I will drop whichever homework assignment helps your average the most. It's not necessarily which homework you did worse on, which is an interesting math problem. As an aside, this is a good time to mention cell phone policy. You guys get to vote. Either A, if someone's cell phone goes off, there's a quiz for everybody in the next class. Or B, if someone's cell phone goes off, they're responsible for getting like Dunkin' Donuts and snacks for everybody in the next class. Dunkin' Donuts. So what you just said, loud voice often wins. My cell phone number is 617-835-3982. You and your friends are welcome to try to call me during class hours. My son is now in 7th grade. My daughter is trying to convince him to try to call me during school days. Now, I am on this regional school committee, and one of the things I get to vote on is whether or not we should ban cell phones during school days for 7th graders. Actually, it's an interesting potential conflict of interest. I am a little bit different than most professors. I am not going to try to get to know you. What does that mean?
We'll have to get to know
you have to make me get to know you. This is far more what real world is going to be like. When you leave the purple bubble, you are not going to have people at big companies wanting to get to know you. Hopefully you'll have some, and hopefully you'll have some mentors. You want to be noticed. So one of the things I always do for my classes is you read Michael Lewis' speech. I actually got up to Coach Williams a few years ago. Fascinating character. And one of the big things in the speech is getting noticed. So happy to go for a walk, grab a coffee, grab a lunch, just sit down and chat. But the burden is on you. And this is a good skill to get. You want to make sure that you do things that can get you noticed. In some of my classes, I often have students write letters of recommendation for the students, which means you've got to be doing things so that people will notice you. When you have a real job, you want to think at the end of the day, what will my boss see and be able to act on? It's just good things to think about. Okay, if I'm in my office, it's office hours. I used to have an email account where people could just log on and send anonymous notes to me. Gmail is changing security. I'm not sure if it's allowable anymore because they always send me new sign-in.
I tried it.
Wait, because now they send me, there's a new sign-in attempt. You want to allow it. And frequently by the time I allow it, people have already left. And so this is one of the problems now. So unfortunately, this worked for many years. I am not an ogre. You please feel free to come up to me with issues. Put an anonymous note under my door if you want. Doesn't have to be an issue about this class, could be in general. A couple of years ago, I was teaching differential equations, and we do not require linear algebra as a prerequisite at Williams. This is wrong, but it was my first semester, first year at Williams, I'm not going to teach things, at least not that early. So linear algebra is not required. We've got to do some system of equations. If we don't do systems of equations, it's a waste of class. So we'll just do 2 by 2. So I asked my students, how many of you know 2 by 2 matrices? Does anybody want a review of 2 by 2 matrices? Everybody's comfortable with 2 by 2 matrices? Okay. Well, we had clickers who said, I'm not going to report back to the class. I'm just curious. How many people would like a review of 2 by 2 matrices? Now, I never said I wouldn't tell other classes. I just said I wouldn't tell the class. 43% wanted a review of 2 by 2 matrices, but not one person was willing to raise their hand. The moral of the story here is if there is something that you are not following and would like me to explain, raise your hand. People are, oh my God, and they'll go like this, they'll roll their eyes something, but inside they go, thank God they asked them. Okay. So almost surely if there's something you don't understand, it's worth asking. It's also a good way to get me to know you. Speak up in class. I forgot to mention this in operations research. You could remind me tomorrow. If you make a good comment in class, tomorrow always means the next class, by the way. I'm not expecting people to come in on Saturday. If you make a good comment in class, email me and I will add that to my grade sheet so that when I'm writing letters of recommendation, I have non-standard things to say about you. If you make a bad comment in class, I will forget about it. Okay. I don't get much sleep. I've got too many things going on. It's very easy for me to forget bad comments. But this is your chance to get me, to know you so that when I write a letter, the letter can actually be meaningful. Too many times you have letters that are essentially, they were in my class, this is when they were in my class, this is the grade they got in my class, by the way, they were in my class. And these letters are not that effective. It's like, oh, so basically you're just saying the transcript is correct. Okay, thank you. So you want letters that can make an impact. I strongly urge you to try to get to know at least one professor well each semester. It does not have to be me, can be me, doesn't have to be. This way, when you graduate, you'll have at least 3 or 4 professors who know you really well. Okay, so my webpage is using state-of-the-art 1990s technology. It always takes me a couple of minutes when I get to a new computer to make it compatible with this primitive program. The reason is when Williams then sends out emails about we are now updating our course management system, I just delete, and I don't have to worry about all the bugs and things that come along with that. It's primitive, but it posts all the information. If there are ever files that you want, any .pdf on my webpage just changes to .tx, and you've got the text source code, it's all there. I might use clickers occasionally. I finished writing the book, but if you are interested in writing a book, I'm almost always working on a book project. I have 2 or 3 going on right now. If you would like to try your hand at mathematical exposition, happy to chat with you about some opportunities. The last one is prepare for class. This must be important because this is being mentioned multiple times. So please arrive knowing the material. If you can't, I strongly encourage you to read ahead. If you can't, have an unpleasant weekend. Read at least a chapter or 2 and get ahead in as many of your classes as you can. That way, when life happens, as it will, you have a strategic reserve that you can chip down. Okay. You never know frequently when an opportunity will present itself. So my thesis advisor is so good, he's lapped the rest of the mathematical community. I am the second Steve Miller he advised. Interestingly, we were both born same year, same city, both Jewish. We both moved out before we were 3 years old. So we didn't meet each other until grad school. And so normally you have birthday parties to celebrate your career as a mathematician if you're really big at like 60 or 75. My advisor did 61. Well, there was already a Steve Miller on the organizing committee. We don't want to have 2 Steve Millers on the organizing committee. So I'm not insulted that I wasn't invited. The other Steve Miller is much smarter than I am, but I was helping them out with a bunch of things. There was going to be a big banquet at the Institute for Advanced Studies in Princeton. I was not going to be one of the people to say nice words about Peter Sinek, my advisor. I was not insulted about that. There were a lot of people who wanted to say nice things about it. But I prepared a speech, just in case. And after the people who were chosen to say remarks, they then asked a few people in the audience, and they came to me and gave me the microphone. And that's when I was extremely glad that I had already prepared and memorized a short speech. So with the cream of the crop of the mathematics community looking on it, good. You don't know when you'll have an opportunity. This is a big theme of the Michael Uslan graduation speech. Prepare for whatever you can. Have things in strategic reserve. Right. So your job is to be prepared for class. Geez, this must be important. If you have questions, come to me, come to the TAs. My job is to provide resources and to be available. All right. Here's advice from my brother, 3 points. Party less than the person next to you. Everybody at least has one person next to them in a generalized setting. Take advantage of office hours and mentoring. When you leave the purple bubble, it is not going to be as easy to have this amount of availability. I was at a school where office hours were 9:30 a.m. the day after homework was due. The students got the message quite clearly. Oh, okay, you don't want to talk to us. I understand. Right? No one is here at Williams for that reason. I almost didn't say that's where that was. Okay, come talk to us, get to know us. And the last is learn how to manage your time. If there's something that can be done easily and not take too much time, do it. If you get an email, respond to it quickly. Even if it's just say, I'm really busy now, I got your email, I'll respond to it in a day or two. You'll let people know that it's been received. I would add to this, have good names for your things. If you want to get me upset and you're wearing a Yankees hat, it's probably the best thing you can do. Just a little bit below that, however, is sending me something, resume.pdf, cv.pdf, paper.pdf. Have good descriptive names. I actually know some Williams students who were not forwarded on to the next level of a job search because that's what they sent. And I had somebody who told me, if I want to send this to my boss, I got to download the file, rename the file, and upload it again so it doesn't get lost on the boss's system or overwrite something already on the boss's system. And application wasn't strong enough for me to want to do that. So please think intelligently. I don't know if I mentioned this elsewhere. I believe everybody here has at least one other class, maybe some activities, maybe who's a senior, maybe looking for jobs. So if you have any deadlines or anything like that, I am happy to work with you around that. If you want practice interviews, happy to do that. I do not grant extensions within 24 hours unless this is like a level of giant meteor has hit your family, something along those lines. You should be managing your work well enough to know if you are going to need an extension well in advance of the due date. The day of is not the time to ask for an extension. Sometimes I have students who are a little bit too kind of, Professor Miller, if we win our next 2 games, if we're going to go into national finals in 3 weeks, thanks for letting me know. We can work that out. I have had many students taking exams at athletic competition, not a problem at all. Just if you think something's going to happen, just let me know so we can plan for it accordingly. How many people are planning on getting a real job and not going to academia? I'll share one other story, if you can remind me for this one for operations research. You can't make this stuff up. A colleague of mine arranged for one of her students at Williams to get a job interview at a big firm in New York City. The firm says, we're really excited to meet with you. We'll see you 8:30 a.m. at our headquarters. And the student writes back, oh, I'm not a morning person. Let's meet in the afternoon. Not only does the student not get the job, my colleague can no longer recommend anyone to this company. So happy to talk to you about some things to think about if you are applying for jobs and stuff like that. A lot of it is really just common sense, but some of the other things you just might not think of. If you're having a Skype interview, you can actually have notes behind your computer that they can't see, which a lot of students don't realize. So there's a lot of things you can do to help out. All right. I want to talk a little bit about looking at plots, looking at data, and trying to glean things from it. So this is a plot of the distribution of sunrise and sunset times in North Adams. You might be able to get it for Williamstown as well, but I went for the closest metropolis. Here's today. Now, when you look at this plot, what strikes your fancy? You're not allowed to speak. You're silent for the next 2 slides.
Oh, like all the oh, it's just
that's September. That's today. That's today's date. Does anything look strange on this? Yeah.
The jumps.
Yeah, there's 2 jumps. What happens? Why do we have these jumps? Daylight savings. So daylight. Okay, yeah. So there's a reason for what's going on. The Earth does not have radically different motion or spin at 2 times of the year. So when you're looking at data, what can you glean from this? Look careful. I am a sports fan. So this is the 2019 Super Bowl. Who is anybody from Hawaii or Alaska? I know they often get upset when you see stuff like this that says America. So who are people rooting for, the Patriots or the Rams? And when you look at this, a couple of things should jump out at you. So what's the first thing you notice? Yeah.
Yeah.
Yeah, you notice Louisiana over New England. So if you don't know anything about the US, this region of the country seems, out of curiosity, who's a football fan? I have issues with the violence of the sport, but my son likes it and I started watching it again. The worst sports quote I think I ever heard was when the Carolina Panthers won the Super Bowl. Anybody remember the Carolina? So the announcers were talking about how the Carolina Panthers are unique among North American sports franchises. They are the only team named after not a city, not a state, but after a region of the country. And isn't it amazing for the Carolina Panthers? Does anybody know who the Carolina Panthers played in the Super Bowl? The New England Patriots. I'm just listening. You realize? Okay, so New England clearly, this is one region. Why is Louisiana rooting for the Patriots? Yeah, the conference championship for the NFC, there was a terrible blown call with 2 penalties. Now, the Rams had bad ball management before this. They should not have been running the plays they were running. But after the game, the defender for the Saints were doing bad play management. The Rams defender who did 2 penalties on the play was dangerous. Yeah, I can't believe they didn't call that. Grabbed his helmet. I did this. I knew if I didn't do something, the game was over. And the refs apologized. The NFL apologized to the New Orleans Saints for blowing the call. So Louisiana was pissed, and so they were not rooting for the Rams. They felt they were cheated. In fact, if you look at Super Bowl viewership, there is a noticeable drop in how many people watch the Super Bowl in New Orleans and Louisiana versus previous years. In fact, a lot of the bars did not show the Super Bowl. They actually showed the Super Bowl from when the Rams won. If you look closely at the map, there is one other place in the country that's interesting. You have to look really carefully. Yes.
Little like dot.
Yeah, do you know where that dot is? St. Louis. Anybody know why St. Louis was reading? Why?
Was like the movement, right?
Yeah, the Rams used to be in Los Angeles, and they moved to St. Louis, and then they moved back to Los Angeles. So there's a lot of information available for stuff like this. I want you to always be looking in a questioning manner about the data. Data can be presented in very misleading ways. One of my favorite examples is, imagine I tell you a team has won 3 out of their last 4 games. That's a 75% playing 750 ball. Is that a good team winning 3 out of their last 4? I mean, does it sound good? What must have happened in their last 3 games? Could they have won all their last 3 games? If they had won their last 3 games, would I have said they won 3 out of their last 4? I would have said they won their last 3. So in their last 3 games, they're 2-1. In their last 4 games, they're 3-4. What are they in their last 5 games? 3-2, because if they had won their 5th game ago, I would have said they've won
4 out of the last 5.
4 of the last 5. So when I tell you they've won 3, I'm looking at it just perfectly to try to influence you in terms of how to view it. Years ago, my family was visiting relatives in California. We stayed at a Best Western. Whoever took the picture of the outdoor pool deserves some kind of award. I mean, they did it in such a way that it actually looked like you could get into the pool. It was the smallest pool we've ever seen, but it was incredible. Or if you watch the previews for some really bad movies like Pee-wee's Big Top Adventure, which are, for 2 minutes you can make almost any movie look good. So when you're seeing data, when you're seeing things presented, always be thinking, who's giving this to me? What is the story they're trying to tell? Statistics, you can manipulate things very easily in terms of what you choose to present, what you choose to focus on. And I want these to be warnings for you. So a lot of stuff comes from gambling. So I will do a little bit more football. The course is not going to be totally on football. I did this because of a student of mine several years ago, Michael Stone, who is my opposite. He roots for the New York Giants to my Patriots, the Yankees to my Red Sox, the Lakers to my Celtics. We don't care about hockey. So to show that I'm not too biased, I said nice things about the Giants once. And then for the rest of the semester, you know. So in 2007, a friend of a student of mine bet $500 at 1,000 to 1 odds that the Patriots would go undefeated and win the Super Bowl. This was the year the Patriots went undefeated in the regular season, won the first 2 playoff games, and lost in the Super Bowl. And so it still hurts to show this picture. It was a remarkable catch. So if he wins $500, 1,000 to 1 odds, $500,000. Now, in the third quarter, Vegas calls him up and offers to buy back the bet 300 to 1. Hello, go Pats! What was his mistake?
There's no reason not to take that. There's no reason like not to take. You have to just take that.
No, because I mean, if the Pats win, you're sacrificing a huge amount of money. This is only $150,000. The other one is $500,000.
But still, if you lose over $500,000, it makes $0.
What should he have done?
Giants.
Yes, it's painful for me to say that. But the correct move here is at the start of the season, you can't bet on every team. The odds are against you because the Vegas has a little bit of an advantage. But at this point, there's only 2 teams left. Put on a secondary bet on the Giants. So let's assume the Giants have probability 1 minus P of winning. So typically we use Q to denote 1 minus P, where P is our probability. And let's say for every dollar you bet on the Giants, you win X dollar. You can plot how much money you would get as a function of, betting. Now what you can do is you can actually make sure you guarantee a certain amount of money. So let's say the Patriots have an 80% chance of winning. Let's say for every dollar you bet on the Giants, you get $3 back. Then we can guarantee, we can find this indifference point where we place a large enough bet on the Giants that it no longer matters to us who wins, the Giants or the Patriots. Now, from a monetary perspective, I want to be very clear from a monetary perspective. Now, when you look at this, is there much of a difference between $350,000 and $500,000 in terms of your life? No, especially with this wonderful thing called taxes. You're going to lose some of that extra $150,000 anyway to taxes. So in terms of the change in your life, guaranteeing $350,000 versus $500,000, go for it. If it was $350,000 versus $50 million, okay, $50 million is statistically different. I'm assuming you have that level of background for this course, okay? So these are the things you want to really be able to think about. You can write some simple code. This is code in Mathematica. You can manipulate, and you can see what happens if you change the probability of the Patriots winning and you change maybe the return on the Giants. And very easy to see how things change and how your optimal should change. Things fortunately got better in later times for the Patriots. Let's see, clicker problems. I'm going to skip the clicker problems and go straight to the hoops game, so we can actually prove something today. All right. Extra credits. I often give cultural extra credit from the 1980s. Can you name the players? Larry Bird and Magic Johnson. It really should be Larry Bird and Michael Jordan, made famous in a bunch of Super Bowl commercials for McDonald's, nothing but net. But I grew up where basketball was very easy. Celtics play the 76ers in the Atlantic Conference. Winner plays the Lakers in the Western. All right. So imagine that Larry Bird and Magic Johnson are playing a simplified game of basketball. They alternate shooting. First one to make a basket wins. We will assume that these are idealized basketball players. Bird and Johnson never get tired. Bird always makes a basket with probability P. Magic always makes a basket with probability Q. As always, X will be the unknown we want to find. What is the probability that Bird wins? Okay. So there are some extreme cases where it should be easy to analyze. Can anybody give me an easy case?
Bird always makes it, and Magic never makes it.
Well, it doesn't even matter what Magic does. If Bird always makes it, Bird will win on his first shot.
So Bird shoots.
Bird shoots first. I'm a Celtics fan. Bird shoots first. I'm going to give myself the advantage. All right. So let's break it into cases. What's the probability Bird wins on his first shot? P. What's the probability Bird wins on his second shot? Sorry.
Q. 1 minus Q.
Not quite.
On that specific shot as also.
So the probability that Bird makes a second basket is P. We've got to get to the point where Bird is making a second shot. What must happen for Bird to get a second shot? He has to miss. And also the other person, yes. So Bird misses 1 minus P, Magic misses 1 minus Q, and then Bird hits. So here I'm using P for Bird and Q for Magic. If you want, you could actually introduce subscripts. I could do P sub B for Bird's probability and P sub M for Magic's probability. You want to think which notation is best. What's the probability Bird wins on his third shot? Miss, 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 miss. Okay, and in a shocker, the probability Bird wins on his nth shot is n minus 1 misses from each. Finally, Bird makes 1. So because we have 1 minus P, 1 minus Q occurring so many times, let's give it a name. And given that, this seems to be looking like a geometric series, let's call it R. That'll be the common ratio. And so if R is 1 minus P, 1 minus Q, then the probability Bird wins is P plus R times P plus R squared times P, and so on. So I pull out the P, and I have a geometric series. How many of you remember the geometric series? You've seen it. How many of you could prove the geometric series formula right now if you'd like to move on? It would be really bad if I had to start up right now. So you can prove the geometric series algebraic, but what I want to do, and this is in line with the philosophy of the course, is I want to give you another way of looking at the geometric series. In earlier years, I would actually bring a basketball net to class and have 2 students play. If people want to do that at some point, I am happy to do that, but I will need people to help me carry it. So we show that this is the probability that Bird wins. It's P times this geometric series, this infinite sum. In general, it is very hard to evaluate an infinite sum. Has anybody taken a class in infinite sums?
Calculus has this.
But there's not that many that we can evaluate. What does calculus normally evaluate?
Series or?
Not series.
Oh, I mean, there's like integrals.
Integrals. So the continuous thing we can do very well. And this is why a lot of things in the real world we model continuously, even though it's discrete. Later this semester, I will be talking about where I have made my fame in the baseball math community for coming up with a theoretical justification of one of the big formulas. And I assume that baseball scores are continuous random variables. I would love to see the Red Sox beat the Yankees by a score of pi to b. Not only would the Sox win, but you get 2 of the greatest constants in mathematics in the scoreboards. Not going to happen. But it's technically easier to allow a possibility like that in terms of doing the analysis. So I want to solve this without using the geometric series formula, and this is going to show a really good concept. So X is the probability Bird wins. So Bird could win on his first shot, which happens with probability P. Now let's assume Bird misses and Magic misses. From this point onward, what is the probability that Bird wins?
The original probability.
Which is?
X.
X. So make sure you email me. I've already mentioned in this class about emailing me. So when you say things like email me, this is the hardest part of the problem. Once they both miss, it's a memoryless process. So the probability that Bird wins from this point onward is X. It doesn't matter what happened to get there. All that matters is we are here. Well, I can solve this equation as you go from the infinite to the finite. And so now we just isolate and we get X is P over 1 minus R. So now we have a formula for the geometric series. And then this is where I'll put up my theoretical hand and say, not quite. For what R have we proven the geometric series formula? We always want to know where things are.
Like there has to be a single shot.
No. That's how we got to this line by having both of them miss exactly once. But for what values of R is this proof valid?
It's like between -1 and 1, probably. It's like, it can't be more than 1 because then the
No,
R.
it actually works as if the absolute value of R is less than 1.
Yeah.
So it could even be complex value. But for what values have I proven this? It's a little bit hard to say this with the year the Red Sox are having, but there are some very bad teams in baseball. So Baltimore Orioles historically have been some good examples. My favorite, however, is the 1899 Cleveland Spiders. So baseball season back then was, I think, 154 games. Do you know how many road losses the Spiders had? Anybody want to guess? 154 games. How many road losses? No, I'm not saying total losses. I'm saying road losses.
Around 70.
Yeah, I'm saying losses on the road versus home. Typically you play half your games at home and half your games away. They actually had 101 road losses. The Spiders were so bad, so few people came to their games that the ticket revenue was not enough to pay the expenses for teams to come to Cleveland. And so teams basically said, screw this. You want to play, you come to us. And so this is one of the unbeatable records. No one's going to break this. They were so bad. But as bad as the Spiders were, what can you tell me about their probability of winning the game?
It's between 0 and 1.
It's between 0 and 1. No matter how bad you are, you can't say, you've got a negative 3% chance of winning today. Or you have a 120% chance of winning. It's always between 0 and 1. So my R is a product of 1 minus P, 1 minus Q. So what possible values of R can I get? Can I get a negative value for R? No. Could I get R equals 0? Yeah, if either P or Q is 1, I can get R equals 0. I can get any number strictly less than 1. Could I get R equals 1? So that would be P and Q are both 0. So what would it mean to have R equals 1? Yeah, the game would just be going on and on and on. Should anybody win if both good and now notice if you put in R equals 1, it does blow up. It's telling you no information. That's good. You always want to check extreme cases for your formula. And so we are only proving this for R strictly between, it could be 0 and then strictly less than 1. With a little bit of work, if you're clever, you can actually get the same result to hold for negative R. There's a nice trick, I'll let you think about that. When my brother was young, he and his friend were playing a very old baseball program on the Apple. I think this was on the Apple IIc. And they decided to create their ultimate players. And I think my brother made the ultimate hitter. Every at-bat was a home run. And his friend made the ultimate pitcher. Every at-bat was a strikeout. So the pitcher always got everybody out, the batter always hit a home run, and they faced off. And the system just, it looked like it hummed. It just froze. We crashed the system, we crashed the system. And then after several minutes, the computer actually answered the problem of, this is the immovable force. Oh, so the irresistible force versus the immovable object. And if you think about it, the answer the computer gave is the most reasonable answer possible. After minutes of thinking, the computer returns double. And a home run is 4 bases, an out is 0 bases. So the computer said, screw this, let's just average, we'll give you 2 bases. You want a sense of what is a reasonable answer. And so when you look at this, when you plug in R equals 1, it is undefined. It's 1 divided by 0. Does that make any sense? Unfortunately, it does break down. Now, typically, what are we going to have? R is typically going to be less than 1. So the denominator is going to be less than 1. Does that make sense? Well, we have P divided by this, right? This is not the probability that Bird wins. It's P divided by this. So I told you that this is undefined when R equals 0. The expression I care about is P divided by 1 minus R. So when R is 0, when R is 1, what must P be? We have 0 over 0. 0 over 0 is undefined. So we're actually in good shape. This blows up, but the numerator is 0 at the same time, so everything's going to be fine. So you want to be very careful about how you take limits and how you look at things. One of my favorite results, this goes back to geometry, I will just mention this. Perpendicular lines meet at a 90-degree angle. There's a beautiful theorem that says the product of the slopes of perpendicular lines is -1. So if I rotate my lines, the slope -1, -1, -1, -1, now I come to the vertical or the horizontal. What's the slope of a vertical line?
Undefined infinity.
Undefined infinity. What's the slope of the horizontal line? 0 times infinity is -1. Right? Because if you think about it, -1, -1, -1, -1, -1, -1, define -1, -1, -1. How should we define 0 times infinity? In this case, we should define 0 times infinity as -1. That's the natural way to define it for this problem. There is a way to extend and continue. A huge amount of advanced probability is working with limits carefully and trying to get a good answer. It is unfortunately very common and very easy to make small algebra mistakes. If you can constantly be checking and seeing, is this reasonable? My physics textbook of thermodynamics had an interesting typo where an ice cube was thrown into the pool and the pool froze. There was a sign error in terms of which way heat was flowing. You should not have the pool freeze. You should be able to realize, this doesn't seem quite right. So you want to get a rough sense beforehand, what should the answer look like? If you have a probability greater than 1 or less than 0, you know you've made a mistake. You may not know where the mistake is, but you know you've made a mistake. I strongly encourage you, when you're doing problems, write some simple code to experiment and see, does my answer look reasonable? If I'm giving you a problem about, shuffling a card deck and having, a certain hand and what's the probability of a certain hand, well, if I can simulate it, then I can get some idea of, I'm off by a factor of 3,000. Okay, maybe I've forgotten something. The other thing is, there are many different ways to program. If you've never programmed before, happy to chat with you. Step 1 is to have something that works. Step 2 is to have something that works well and works efficiently. So there are often tricks you can do. Let's say and we'll end with this. I want to shuffle a deck, I deal 5 cards, and I want to know what's the probability I get at least 2 queens. Well, I can create an entire deck. I can assign, 52 different values. But if I only care about kings, I can make a king be a 1 and have 4 1s, and then every other card can be a 0. How many of you have ever done Sudokus? So if you want to check and see if a Sudoku is correct, do I have the numbers 1 through 9 in each row, in each column, in each block of 3? So how many checks is that? So we have 9 rows, 9 columns, and 9 blocks. And then for each row, we have to make sure, do we have a 1, do we have a 2, do we have a 3? That's 9 checks for each row. So that's 81 checks just for the rows. I can show you how to check a row with just 1 check. Does it matter if I use the numbers 1, 2, 3, all the way up to 9? Could I do broccoli, cauliflower, spinach, carrots? Could I choose 9 vegetable symbols?
So as long as you don't have any repeats, the rows correct.
But then there's a lot of things that you're checking, and you have to check and see, do I have distinct things? Take the numbers 1, 10, 100, 1,000, etc., and check and see if the sum 111 million, 111,000, 111. The only way you can get that sum is if each thing happens once and only once. If you use the numbers 1 through 9, if I change a 2 to a 1 and an 8 to a 9, it's going to still have the same sum. So a lot of times, you can write a general code which would be useful for a variety of problems, or you can specialize your code to the particular problem you care about. And if I only care about these features, let me make my code focus just on that. All right, we have about half a minute left. Any general questions? Yes?
You put these lectures on.
The lectures will be online. So this is the only one where I'm hoping it will be recorded well. I'm trying to record it through my computer and trying to have it recording like this as well. I will have to figure out how to place the camera recording system to capture this, as well as to capture the board.
Listen to you also the power.
Yes, yes. Most of the lectures will be chalk lectures, though.
What requirements do you have for projects?
Basically, talk to me. I'm happy to consider a variety of projects from something very theoretical to something very applied and working with a local company to see maybe how we can do things, help them do better. All right. Have a good day. Have fun with the lunch rush.